On a Friday evening in April of 2029, a little over 2 billion people are going to walk outside, look up, and watch a star cross the sky that has no business being there. It will not streak. It will not flare. It will simply move, steadily, the way a satellite moves. Except this one will be brighter than most of the stars around it, and it will take the better part of an hour to cross. And it will be closer to you than the satellites that carry your television signal. I want to be careful with you from the very first minute, because this is a story that has been told badly for 20 years. And it has been told badly in both directions. One half of the internet will tell you this thing is going to hit us. It is not. The other half will tell you the scare was always nonsense, that scientists overreacted, and there was never anything to it. That is not true either. And the reason it is not true is the most interesting part of this entire story. So hold 3 things for me. First, for a few days in December of 2004, this object was rated more dangerous than anything humanity has ever put a number on. Not in a tabloid, on the official scale, by the people whose job is to be calm. Second, the thing that saved us was not a deflection, or a mission, or a plan. It was an old photograph. Someone went looking through images taken before anyone knew this rock existed, and what they found in that archive changed the answer. And third, on the day it passes, Earth is going to physically alter it, reach out across 30,000 kilometers of empty space, and change the shape of a mountain. We have never once watched that happen, and in 2029, we will have a spacecraft parked there to film it. Let me take you through it properly. It begins in Arizona, in June of 2004, at Kitt Peak. 3 astronomers, Roy Tucker, David Tholen, and Fabrizio Bernardi, pick up a faint, moving point of light. They track it for 2 nights, and then they lose it. The weather turns, the object drifts out of reach, and it becomes what astronomers call a lost object. A thing you know is out there, with an orbit you cannot pin down. It stays lost for 6 months. In December, it is found again, from Australia. And now there are enough observations to actually run the numbers. And the numbers come back wrong. Here is what I mean by wrong. There is a scale for this called a Torino Scale, and it runs from 0 to 10. 0 means no hazard at all. 10 means a certain collision capable of causing a global catastrophe. Almost every object ever measured sits at 0. A handful have touched one, which means a routine pass that merits attention and almost always drops back to 0 within days. In December of 2004, this object reached 4. 4 has never been reached before or since. 4 is defined as a close encounter meriting concern by astronomers, with a 1% or greater chance of a collision capable of regional devastation. At its peak, the calculated probability was about 2.7%, roughly 1 in 37. I want you to sit with that number, because I think people hear a small percentage and relax. Imagine being told there is a 1 in 37 chance that a city-sized region of Earth is destroyed on a date you can already write in a calendar. That is not a rounding error. That is the kind of number that makes serious people stop sleeping properly. And the date it kept returning was the 13th of April, 2029, a Friday. I should tell you what regional devastation actually means, because the phrase is doing a lot of quiet work in that definition. An object of this size, arriving at these speeds, does not behave like a bomb, and it does not behave like a bullet. It arrives carrying an amount of energy measured not in tons of explosive, but in hundreds of megatons, which is to say considerably more than every weapon detonated in the whole of the 20th century, delivered into one place in under a second. It is not big enough to end us. That is the honest and important distinction, and the doom channels flatten it constantly. This is not the class of object that killed the dinosaurs. That one was measured in kilometers, not hundreds of meters, and it is a different category of event entirely. But it is very comfortably large enough to erase a metropolitan area. And if it came down at sea, which is where most of the planet is, it would arrive as water rather than fire, and the coastlines facing it would take the consequence. So when that scale said regional devastation, it meant something specific and survivable and utterly unacceptable. A country losing a city or a coast on a date already written down. That is what was on the table in December of 2004, at one chance in 37. They named it Apophis. In Egyptian myth, Apep, which the Greeks wrote as Apophis, is the great serpent of chaos who lives in the dark and tries every single night to swallow the sun. Two of the discoverers were fans of a television program that used the name for a villain, and that is the honest reason it was chosen. But the older meaning is the one that stuck, and I understand why. A thing that comes out of the dark on a schedule. Now, the part everyone gets wrong. The scare did not end because someone found an error. It ended because someone found an older picture. When you have an object's orbit, the single most valuable thing you can add is not another observation tonight. It is an observation from years ago, because a longer arc of time constrains the path enormously. So astronomers went digging through archival images, plates, and digital frames taken by surveys that had photographed that patch of sky before anyone knew there was anything in it. And they found it. Apophis, sitting unnoticed in images from March of 2004, months before its official discovery. A pre-covery, they call it. Recovering an object from a past nobody knew they had recorded. That extra arc collapsed the uncertainty. The probability for 2029 fell to essentially zero within days. I find that quietly extraordinary. The thing that took a 1 in 37 chance of regional devastation off the table was not a rocket. It was a filing cabinet. Somebody had pointed a camera at an empty-looking piece of sky and stored the result. And that stored result was the answer. But the story did not close there, and this is where most retellings stop far too early. Removing 2029 did not remove the problem, because of something called a keyhole. When Apophis passes us in 2029, our gravity will bend its path. Where exactly it goes afterwards depends with terrible sensitivity on precisely where it passes through. There are narrow regions in that flyby, some of them only a few hundred meters across, and if the asteroid threads one of them, Earth's gravity aims it at us for a later return. 2036 was the one that worried people for years. So for roughly a decade and a half, Apophis stayed on the risk list, not because anyone thought it would hit in 2029, but because nobody could yet prove it would miss the keyholes. That took until March of 2021. Radar. Goldstone in California, working with other dishes, bounced signal off it and measured its distance to within meters. With that, the path could be projected forward cleanly, and Apophis was removed from the risk table entirely. No impact risk for at least 100 years. 17 years, from a number nobody had ever seen before, to a clean bill of health. Now let us go to the day itself, because the flyby is genuinely without precedent for something this size. On the 13th of April, 2029, Apophis passes about 31,600 kilometers above Earth's surface. That number means nothing until you put something next to it. The satellites that carry television and much of our weather imaging sit in geostationary orbit, 35,786 kilometers up. Apophis will pass beneath them, a rock roughly 340 meters across, comfortably larger than most skyscrapers are tall, will move through the space between our satellites and our atmosphere. Objects that size come this close on the order of once every several thousand years. Not once a decade, not once a lifetime, once in a span longer than recorded history. And you will see it without a telescope. It will reach roughly magnitude 3, which puts it in the same brightness range as an ordinary star in a familiar constellation. It will be visible first from the night side, sweeping up over Europe and Africa and Western Asia, and something close to 2 billion people will be standing under a sky where it is visible. No equipment, no app. Go outside, look up, and there is a mountain moving. And I want to describe that properly, because I think people picture a fireball and then feel let down by the reality. It will not look violent. It will look calm. A steady point of light, no tail, no sound, sliding across the constellations at a pace you can actually perceive if you hold still and watch. Line it up against a rooftop or a branch, and you will see it leave that mark behind in under a minute. The strangeness is not in the spectacle. It is in what you will know while you are looking at it. That the point of light is a solid object 300 meters wide. That it is below the satellites. And that for a few days, 25 years earlier, a small number of people looked at that same object on a screen and could not rule out that this was the night it arrived. Which brings me to the third thing I asked you to hold. And it is the part that made me want to make this video at all. We are not just going to look at it. We are going to watch Earth change it. Apophis is not a solid boulder. Most asteroids that size are better described as loosely bound piles of rubble, held together by their own faint gravity, with dust and gravel and boulders resting on the surface at angles that would collapse instantly under stronger pull. When it passes inside 32,000 kilometers, Earth's tidal forces will act across it. The near side is pulled harder than the far side, and on a body held together that weakly, that difference is expected to be enough to do things. Landslides, boulders shifting, fresh material exposed to sunlight for the first time in a very long time. Seismic shaking. On an object with no atmosphere to muffle it, it may also change how it turns. Apophis does not rotate cleanly like a planet. It tumbles in what is called a non-principal axis rotation, wobbling as it spins. That tumble is expected to be disturbed by the encounter. So on one evening in 2029, a planet will reach across empty space and rearrange the surface of an asteroid, and we will be close enough to watch it happen in detail. We have never had that. We have cratered an asteroid on purpose, and we have nudged one, and both of those were extraordinary. But we have never watched a natural encounter reshape a small body in real time. Everything we believe about how rubble piles hold themselves together, how their surfaces behave, how strong they actually are, gets tested in a few hours. And that matters beyond curiosity. If we ever do have to move one of these, the single most important thing to know is what it is made of and how it holds together. You cannot push a rubble pile the way you push a rock. Apophis is about to run that experiment for us, for free, with Earth as the instrument. Which is why there's now a small race to be there when it happens. Europe has committed to a mission called Ramses, built specifically to rendezvous with Apophis and be in position before the flyby so it can survey the asteroid in detail beforehand and then observe it through the encounter and afterwards. The whole scientific value depends on that ordering, a before and an after of the same object, with the change happening in between. Miss the before, and you are left wholly an after with nothing to compare it to. And there is a second spacecraft already in flight. The probe that visited the asteroid Bennu and returned a sample to Earth did not shut down after that delivery. It was given a new name and a new target, and it is on its way to arrive at Apophis shortly after the flyby to spend months studying what the encounter left behind. There is something I find genuinely moving about that. A machine that has already completed its mission, already sent its cargo home, given a second life, and pointed at a rock it will not reach for years, so that it can be standing there on the far side of an event that has not happened yet. Let me be straight with you about the uncertainties, because I would rather you hear them from me. We do not know how much Apophis will actually change. The predictions range from dramatic resurfacing to something quite subtle, and honest researchers will tell you they are not certain which. We do not know precisely how much rubble will move, or whether the surface changes will be obvious or will need careful measurement to detect at all. And mission schedules slip. They always do. The plan is sound, the funding is committed, and the date is fixed by orbital mechanics rather than by anyone's preference. But 3 years is 3 years. What is not uncertain is the flyby itself. That is locked. Gravity does not renegotiate. So let me pull this together before I let you go. A rock was found in Arizona, lost for 6 months, and found again with numbers that put it higher on the hazard scale than anything before or since. 1 in 37 for a Friday in 2029. The thing that took that number away was not a spacecraft. It was an archived photograph of a piece of sky nobody thought was interesting. It still took another 17 years and a radar measurement accurate to meters to close the question completely. And now the same object that once frightened everybody has become the most valuable free experiment in the field, because on the day it arrives, our own planet is going to reach out and rearrange it while we watch from a few kilometers away. If you want more stories like this one, told properly, subscribe and stay with me. I would like the company. Because here is the part I keep coming back to. For most of human history, an object like this would have arrived unannounced. It would have crossed the sky and people would have made of it whatever their fears allowed, and then it would have gone, and nobody would have known how close it came or whether it was ever coming back. We know. We know the day, we know the hour, we know the distance to within meters, and we know it will miss, and we know it will miss again for at least a century after that. We worked that out with old photographs and radio waves and a great deal of patient arithmetic, and we did it decades in advance. And so on that Friday evening, when 2 billion people go outside and look up at a moving point of light, almost none of them will be afraid. That is not a small thing. That is the whole achievement, standing in the open where anyone can see it. I will be watching, and when it comes, you and I will look up together.